Good morning, fellow students. Today we'll talk about neutralization. You can see in this PowerPoint, there's some N-acid triplets, right? This N-acid triplet is used to relieve pain of our stomach. One of the reasons we get stomachache is that our stomach produces too much acid. As you know, actually, our stomach would produce concentrated hydrochloric acid to digest the food we intake. But if the stomach produces too much acid, we would get stomachache. We will feel pain in our stomach. So that we will take these pills. These pills are antacid. They are alkaline. They help us to neutralize the excess acid in our stomach. So what is neutralization reaction? Neutralization actually is a chemical reaction, 化學反應. When a chemical reaction happens, new substances are formed. In this experiment, we'll look at the change in pH during neutralization. So please watch the video of this experiment. Observe the results. First of all, we put some dilute hydrochloric acid into the conical flask. We use a measuring cylinder to measure 10 cm³ of dilute hydrochloric acid to the conical flask. And then we'll add universal indicator to the acid. So do you remember what will be the color change? So we add 3 drops of universal indicator. Before looking at the answer, guess what is the color change? Shake the flask gently. As you can see, the color changes to red. We have to match the color of the solution to the pH chart. We can see that the pH value is approximately 1. You can see we will put the conical flask on the white tile. That is because the white tile helps us to observe the color more clearly. And then afterwards, we'll add 1 cm³ of dilute sodium hydroxide solution into the conical flask using a syringe. Sodium hydroxide is alkaline or acidic? Do you remember? I give you 3 seconds. Time is up. Yes, it is alkaline. We will add the sodium hydroxide solution 1 cm³ by 1 cm³ to the conical flask to observe what will be the color change. Whenever we add the sodium hydroxide solution, we'll have to shake the flask gently and match the color of the solution with the pH color chart again to get the approximate pH value. We will have to record the pH value of the solution in this table. Repeat the steps. until 15 cm³ of dilute sodium hydroxide has been added. That means we have to add 15 more times the sodium hydroxide solution into the conical flask. Again, observe the color change of the solution. Record the pH of the solution in this table. You can see the result is something like that. What is the characteristic of the result? What does the result show? Actually, you can see that at the beginning of the experiment, when 1, 2, 3, 4 cm³ of sodium hydroxide is added to the solution, the pH value still 1, right? But when 5 cm³ of sodium hydroxide is added, the pH value started to rise. But still, the pH value rises slowly. Why the pH value will rise? As you remember, hydrochloric acid, of course, it is acidic. But sodium hydroxide is alkaline. So the alkaline substance would neutralize the hydrochloric acid so that the pH value would rise. You can see at 10 cm³, the pH value suddenly rises to 7. This is the point when the acid and the alkali, that is sodium hydroxide solution, completely neutralize. What does pH 7 show? It shows that the solution is neutral, 中性. After that, when 11 cm³ of sodium hydroxide is added, the sodium hydroxide, which is alkaline, is in excess. When it is in excess, you can see that the pH value rises to 12 or 13. It shows that the solution becomes alkaline afterwards. So when we put the results into a graph, it would be something like this. At the beginning, the pH value rises slowly, and at around 10 cm³, the pH suddenly rises to 7, and afterwards, the pH rises to 12 or 13, so that the solution is alkaline. So can you answer this question? Actually, I have explained it before. Can you answer the question by yourself? How does the pH of the resulting solution change? When dilute sodium hydroxide solution is added in the beginning, the pH rises slowly. That is this part. And then, just before and after the solution reaches 7, that is becomes neutral, the pH suddenly rises to 7. This is the point when the acid and alkali just neutralize. This point, we call it equivalent point. We'll learn this in the senior form. And then afterwards, when more dilute sodium hydroxide solution is added, the pH value increases to about 7. it shows excess sodium hydroxide solution is present. There's this part. So when you look at the graph, how much dilute sodium hydroxide solution is needed to neutralize 10 cm³ of dilute hydrochloric acid? It should be 10 cm. 10 cm³. Actually, in this experiment, we are using the same concentration of sodium hydroxide and hydrochloric acid. Okay? We'll learn about concentration in linear form. Okay, so don't be confused that 10 cm³ sodium hydroxide must need 10 cm³ of hydrochloric acid to neutralize. No, not in all cases, but only in the cases when they are in the same concentration. So this is what we can see from the graph. In experiment 9.8, again, please watch the video to look at the results. I will go through this experiment to you. This experiment is to find out what substances are formed during neutralization. As you remember, neutralization is a chemical reaction. Whenever there is chemical reaction, new substances are formed. First of all, we put 10 cm³ of dilute hydrochloric acid into the conical flask using a measuring cylinder. And as you remember last time, in the last experiments, how many cm³ of dilute sodium hydroxide is needed to neutralize the dilute hydrochloric acid? That is 10 cm³, right? So this time we add 10 cm³ of dilute sodium hydroxide solution into the conical flask. Observe, is there any color change? I give you 3 seconds. No, there's no color change. But why in the previous experiment we have color change? I give you 3 seconds. Yes, because we have added universal indicator in the last experiment. This time we don't need any indicator because we are looking at the product of neutralization. So you can see that there should be no color change. You can refer to the video for clearer results. Shake gently to get the neutralized solution. And then using a dropper to transfer the neutralized solution to the watch glass. And then we will put the watch glass over a hot water bath. And you can see that the liquid on the watch glass becomes smaller and smaller volume. Boil until all liquid on the watch glass has evaporated. There should be something remain on the watch glass. Again, watch the video for the better results. We have to observe the residue, that is the solid left on the watch glass. What's the color of the residue? We can describe the appearance of the residue on the watch glass. What does it look like? It could be some white solid. Actually, these white solid are table salts. When all the liquid evaporates. This white solid, that is table salt, left on the water glass. How can we prove that they are table salt? Sorry, in Form 2, we have no method. But if you go to senior form, if you study chemistry, there's some method to test if it is table salt. Table salt 食鹽啊，你屋企食得嗰啲鹽叫做食鹽 table salt. We can use a flame test, FLAME, flame test, and silver nitrate test to test if it is table salt or not. But unfortunately, in Form 2, we won't try this test. Okay? So please look forward to your senior form. But I can tell you that these white solid form are table salt. So what is the liquid evaporated? Actually, the colorless liquid evaporated is water. So in conclusion, what is formed when an acid is mixed with an alkali? When they neutralize each other, salt and water are formed. But please be reminded that actually in our world, in our nature, there's many kind of acid, many kind of alkali. If we use different kind of acid and different kind of alkali, they can form different salts. Of course, same water. Okay, there's only one kind of water in our nature. Okay, but for salt, there are many kinds. Some of them can be eaten, just like table salt. They are edible. But most of the salts, we call them chemical salts. They cannot be eaten. They are toxic. So don't think that all salts are edible. Some of them are just chemical salts. If we use different acid and different alkali, we can get different salts. On page 30 and page 31, there's some word equation showing different acid mixed with different alkali. These parts won't be examined. Page 30 and page 31 won't be examined. This is very important, right? But it is still quite interesting to look at the word equation because it tells us that if we use different acid and different alkali, they can form different salts, just like first one. Sodium hydroxide mixed with hydrochloric acid. Actually, we have performed or watched the video of these experiments before. It formed sodium chloride, 氯化鈉. That is table salt. Actually, sodium chloride is the salt at our home. Okay. 而家成日買啲生理鹽水，佢成分就係 sodium chloride solution. But if we use another alkali, that is potassium hydroxide, and another acid, that is nitric acid, 硝酸, it forms another salt. This salt cannot be eaten. That is potassium nitrate. It can be used as fertilizer. Another example, that is we use sodium hydroxide and sulfuric acid. When they mix together, it forms another salt, that is sodium sulfate. Again, this salt cannot be eaten, but it can be used as washing powder. So we'll learn this equation in the senior form, okay? But it is not required in Form 2 level. Okay, we talk about more about neutralization next time.